Welcome back. So in the last lesson, we saw how Kathy created her tables. You may be good with how the create statement looks and identifying the data types of each column, but you may be asking yourself, was it really necessary to create so many tables? Couldn't Kathy have created one super table instead? That is a very valid question. Today we are going to talk about this thing called normalization and explain a bit more about the design of Kathy's Cinderella 1 schema. And who better to help us than our friend Norma, Notnormal. After today's lesson, you will be able to explain what normalization is and learn 3 basic normalization rules. You will see how following normalization rules is helpful, and you will better understand why Kathy Creator created many tables in the Cinderella 1 schema compared to one super table. So normalization is basically a set of rules to follow to make the database as efficient and effective as possible. And this basically means not having lots of data duplication within tables and not having lots of blank empty space under columns. To show what normalization means, we are going to go over some basic rules in normalization and show what it looks like when these rules are broken, best exemplified by our friend but not colleague, Norma, Notnormal. So first we're going to talk about the normalization rules, then we'll see some examples. So rule number 1, do not have repeating columns in an individual table. Multiple columns that store pretty much the same thing. Rule number 2, each row in a column should have a single attribute. So like in our subjects table, we'd only want to store one person's name, not all of the subjects' names. Rule number 3, each table should only be about a specific topic, and only those columns which support that topic should be included. So now let's meet Miss Norma Notnormal and go into what these rules really mean. Norma Notnormal actually started on the team prior to Kathy Creator coming on board. Before our interview with Norma, Cinderella and I had just had a lovely tea party, but since there was a tea shortage, we had pink bubbly champagne instead, and I admit that we may not have been our sharpest selves during our interview with Norma. She was very sweet and we hired her on the spot to be in charge of database design and table creation. Norma, like Kathy, started her database design by talking to Cinderella about her data needs, and once she had a pretty good idea of what Cinderella wanted to store, Norma, Notnormal, moved on to table creation. When Norma was finished with her design process, she proudly presented her work. She showed Cinderella and I the single table she had designed to store all of Cinderella's data. Take a minute to look at it and see if anything pops out here. Norma wasn't following normalization rule number 1. She had several columns that had repeating columns in a single table. So even though the column names were slightly different, she was storing parties that the subjects attended in multiple columns in the same table. So she had party 1 name, party 2 name, party 3 name, and the corresponding dates. Let's take a look at what a sample result set pulled from this table would look like. Take a moment to look over the data returned and see if anything stands out. So let's look more closely at the first 2 rows of data and talk about what is going on. First, we see Mirabelle Mihungi. The first few columns look alright, just some information about Mirabelle. Then let's take a look at the columns that hold information about the parties that Mirabelle attended. So it looks like under the column party name 1, Mirabelle attended the pink party. Under the column party name 2, Mirabelle attended Where My Party Subjects At. Under party name 3, Mirabelle attended Scarily Ever After. One thing about this design is what happens when Mirabelle attends more than 3 parties. Mirabelle's a pretty avid party goer, so she would certainly attend more than 3 parties. Either Norma would have to add columns for hundreds of columns for all the parties that subjects would possibly attend, or Cinderella wouldn't be able to see all of the parties that Mirabelle attended. So it's not looking like a great design. Let's move on to Xavier. We can see the first few columns look good, where it tells his personal information, but let's look at his party name 1. It looks like he didn't attend the pink party, so his party name 1 is where my party subject's at. This presents another problem. If you notice, Mirabelle's party name 2 is where my party subject's at, and Xavier's is party name 1. So if Cinderella wants to see subject information about subjects that attended where my party subject's at, she would have to look through every single column to see if it contained that party name. And this would be some pretty complex SQL. So it doesn't look like having a new column for each party attended by the subject is an ideal way to design this table. So let's take a look at Iggy Agora's row. Iggy is not one for the parties and really doesn't attend many. However, because many subjects will attend many parties, there are several columns for parties in Norma's design. These columns will be all blank for Iggy. So this is not necessarily the most efficient use of space. All of these concerns were presented to Norma, and she went back to the drawing board and presented a new table. See if you can spot what normalization rule is being broken here. Before we talk about the specific normalization rule broken, let's look at a sample result set. So Norma has a column for parties and a column for party names and party dates that the subjects attended, and it is intended to store multiple party names and dates based on how many parties the subject attends. So we can see Mirabelle's list of party names and dates. Although this gets rid of the multiple columns to store the same thing, it would make the SQL statement to get data out very tricky because we don't really know the order of the parties that she's attending. So the normalization rule being broken here is normalization rule 2. Each column should only store a single attribute. So only one party name should be stored in this column, not a list of party names. We advised Norma that we still weren't satisfied with the super table she presented. So Norma went back to the drawing board again. This time she came back with a table that looked like this. Let's take a look at the sample results from this table to see if we can identify the normalization rule being broken. We left out Mirabelle because we didn't have enough space for all of the rows to show her, but let's just take a look at Xavier and Aggie. See if you can spot anything that looks a little not normal or wasteful. If we look at Xavier, we see he has multiple rows, one row for each party he attended. The party information looks great, but one thing that doesn't look so great is the duplicated data. We are storing repeated personal information about Xavier for every single party he attends. That's a lot of duplicates. Aggie's doesn't look as bad because he doesn't attend too many parties, but there are still quite a few blank spots. The normalization rule being broken here is each table should be about a specific topic, and only those columns which support that topic are included. So in the subjects table, in Norma's subjects table, we have subject personal information like marital status, date of birth, gender, tagline, phone number, address, kingdom, active subject. But we also have information about parties that the subject attended, like the party name, the party score, and if they RSVP'd on time. So now that we saw what not to do, how could these tables be more normal? Because we are storing information about subjects and information about the parties they attend, we could break up the tables and create two tables. One that stores subject information and one that stores party information about the parties they attended. So we have subjects and party attendance. Let's take a look at a sample result set. We can see that Mirabelle, Xavier, and Aggie all have one single row in the subject table with no duplicate data and no blank spots. We can see that Xavier and Mirabelle each have 3 rows in the party attendance table for the parties they attended, and will have additional rows as they attend more and more parties. Although their names are in both tables and are repeated in the party attendance table, the additional information like their gender, marital status, and date of birth are not repeated. Also note that Aggie doesn't have any rows in the party attendance table, so you don't see all those blank fields for his row. So hopefully now you are starting to see how following database normalization rules is a more efficient way of storing data than not following normalization rules. You don't have to be a pro at designing databases, but hopefully this lesson will give you a little insight into why most database designers will create so many tables. So now it's time for an activity to cement what we learned today, and then on to lesson 7, where we put the relation in relational databases with a lesson on primary keys, the link between tables.